Right, we're going to talk about atomic theory, and today we're going to specifically talk about Dalton's atomic theory and then the modern atomic theory, and then why those theories are important to us. So, this is basically why atoms are the way they are, and we're going to have a little bit of background. So, first, just remember that an atom is the smallest unit of an element. You can't break an atom down and still have the same properties of that element. The first suggestion of atoms were back from the Greeks, and they first started using that word atom. And then, how are the atoms built? We know that atoms are built out of protons, neutrons, electrons, and not all of that was put together yet at the time when some of the stuff was first put together. So we're going to talk about who was the first guy that we really care about, and that's Dalton's atomic theory, at least for our class, who we really care about, and that happened in 1808. So I have this date here. I don't need you to memorize the date, but it's more of what's the timeline of how these things are happening. So he came up with this theory that was based off of other people's works, and he just kind of put it all together into something that was coherent and made sense based off of his observations. So first he said that all elements are made out of atoms, and then for those atoms, the of a given element, they're all identical. So if you have carbon atoms, they all look like carbon. If you have oxygen atoms, they all look like oxygen. But then if you compare carbon and oxygen, they're different, so atoms of different elements are different. He then went on to say that we can take those atoms and put them together to make compounds. And then specifically, a compound has a specific ratio of elements. And then finally, he said that we can't break atoms down in a chemical process. We can only change those groupings of atoms when we change to different compounds. So that's what Dalton came up with. And one of the reasons why this is important is because it led to a few laws. So the first law, known as the law of constant composition, which can also be called the law of definite proportion. So if you think of the word constant and definite, that means like stays the same. So what that law is saying is if you have a compound, the formula is always going to be the same. So water, H2O, is always going to be H2O. It can never be H3O or just HO. It's always H2O. That's what water is, and it has a specific set of properties. But we can take those same atoms, H and O, and we can do them in a different ratio, for example, H2O2, and we'd make a different compound. So we can do a different proportion, a 2 to 2 proportion, a different compound with different properties, and that's hydrogen peroxide. So we have water, hydrogen peroxide, two different compounds, and that's how these two laws work. And then lastly, the law of conservation of mass or law of conservation of matter. I call it the law of conservation of mass matter because we look at it in two different ways, which is saying that we can't lose atoms. We can't break them apart. We have to be able to account for all of our atoms, which comes into play for balancing chemical reactions later on in the school year, and then also for lab experiments where if we start out with 10 grams, we have to finish with 10 grams, and if we lose some of that mass, quote unquote lose, it had to go somewhere. Now, what we found out over time is that some of his Dalton's theory isn't exactly true. That's the thing with theories. Theories explain something that we see in nature, explain how it works. And we found out more information, we have to change this theory. And that's where the modern atomic theory comes. It's the same as Dalton's atomic theory except for point 2 and point 5. Point 2 was that atoms of the same element are the same. Well, we found out that there's isotopes. So that means that atoms of the same element don't have to be exactly the same, but pretty much the same. And sometimes their masses are different because they have different numbers of neutrons, and that would be different isotopes. And for a given atom, really isotopes behave pretty similarly, but there are some subtle differences. And then we also learned that atoms can be broken down in a nuclear reaction. So we had to clarify point 5 and say that it has to be just a normal chemical reaction. If it's a nuclear reaction, we can split those in half. And we saw that with the advent of nuclear reactors and nuclear bombs and some of Einstein's work. So when new observations were found, we had to change the theory, and that's what we kind of work off now is the modern atomic theory. So what you should have learned in this video is that we have this guy named Dalton. He had 5 postulates called his Dalton's atomic theory. And then some of those postulates make some pretty important fundamental cornerstone laws of chemistry. And then after information was found, we had to change it into the modern atomic theory. Basically the same theory, we just subtly changed it. We didn't dump the whole theory. We just made some modifications that fit the new data that were found. Hope that helps.